Hello everyone, today we're tackling a topic you might not know about, lithium batteries. Indeed, most of your household devices use lithium batteries, which are rechargeable and recyclable. Lithium mining is concentrated in a handful of regions worldwide, mainly due to specific geological conditions necessary for its concentration. It's generally found in South America, Australia, Africa, and many other places. This is because lithium is a light element and has an electron in its valence shell that it wants to get rid of. These batteries have become the industry standard thanks to their high energy density and long lifespan. Understanding how they work not only allows us to optimize their use but also ensures the safety of installations. Because there have been numerous accidents involving these types of batteries, including explosions and unpredictable fires. Now, let's get down to business. A lithium battery doesn't generate electrons, it moves them. The principle is based on intercalation. This involves the movement of lithium ions between two electrodes through a liquid or gel electrolyte. The anode, usually made of graphite, stores electrons when the battery is charged. The cathode, on the other hand, is the positive electrode during discharge. Its role is fundamental as it largely determines the battery's performance, voltage, and safety. Next, there is the electrolyte, a lithium salt in an organic solvent, which allows the passage of ions while blocking electrons. Finally, there is the role of the separator, a microporous membrane that prevents direct contact between the anode and cathode, thus preventing a short circuit that could damage the battery. To better understand this process, imagine the battery as a kind of chemical pump that separates the charges to force them to work. The electrolyte acts like a one-way gate. It allows ions to pass through, but it insulates electrons. The electrons are therefore trapped inside the anode and desperately seek another path to reach the cathode. Since the electrons cannot pass through the electrolyte, they take the only remaining path, the electrical wire that connects your device. As this wire flows, the current of electrons creates the electric current. This is precisely the principle that factories exploit for the mass production of batteries for electric cars, laptops, and many other devices you likely use. So, you understand how it works. Let's move on to the essential safety rules to know when you own this type of battery. Rule number 1. Never use a lead-acid battery charger. Lithium requires a specific cycle, meaning a constant voltage and current. Therefore, it is absolutely essential to use a specific charger. Lithium batteries require a specific cycle, that is, a constant voltage and current. Rule number 2. Never exceed the current recommended by the manufacturer. Charging too quickly will overheat the cells. Monitor the end of the charging process. Even if the charger is automatic, do not leave a battery charging unattended for an extended period. A BMS, battery management system, is mandatory. Never use a lithium nude cell without one. It is the BMS that cuts off the current before the voltage becomes dangerous. Avoid deep discharge. Rule number 3. If a cell drops below its critical voltage, usually 2.5 volts, its chemistry is permanently altered. It can become unstable during the next recharge. Rule number 4. Controlled temperature. Store your batteries in a dry place, between 15 degrees Celsius and 25 degrees Celsius. Heat above 45 degrees Celsius is the number one enemy of battery lifespan. Rule number 6. Keep away from flammable materials. In the rare event of a fault, a lithium battery can burn with extreme intensity. Do not store them near chemicals or dry wood. Rule number 7. Tool insulation. When assembling the battery, use insulated tools. A short circuit caused by a metal wrench on the terminals can release hundreds of amps instantly. And finally, the last rule is this. Cable cross-section. Use cables of sufficient cross-section. Cables that are too thin overheat, and this heat is transferred directly to the battery terminals. That's all for this video, folks. I hope you enjoyed it. Don't forget to like and subscribe, and don't forget the notification bell. Leave your comments below, and I'll see you in a new video.